Ladies and gentlemen, once again, this is Fraser Nation. We're going to start off our new unit talking about logarithmic functions. We have two objectives today. The students will be able to evaluate expressions and will be able to solve equations involving logarithms. Put a little S right there. Remember, a power has a base and an exponent, so anything that looks like, let's say something like a to the x. This is your base right here. And of course, your exponent is a little tiny number that's floating up. Inverse operations undo each other, so anytime you have, I guess something like x minus 2 equals 5, the inverse operation is going to be plus 2 and plus 2. So, that's what I mean when I say inverse operations. Product means multiplication, quotient means division, and finally, there's been some topics in the past where when you multiply, you add, when you divide, you subtract. Well, that comes again later on during this lesson, so let's go ahead and move forward. You do not have to write this down. I put this here because some of my students may not remember this stuff, so this is optional. If you want to write it down, write it down. If not, then go ahead and move to the next slide. We have some things that we can put in here. It's just basically things that you do with exponents when they have the same base. So notice something like product of powers. If I had something like 2 to the third and 2 to the times 2 to the, fourth, you got to add the exponents. So this would be 2 to the seventh. Something that probably is really important in this lesson is going to be the negative exponents property. You basically switch your base to the other side of the exponent. I mean, not exponent, the fraction. So if it's on the top, then it's going to move to the bottom. If it's at the bottom, it moves to the top. So something like 2 to the negative 2 is going to equal to 1 over 2 to the 2 power, which is equal to 1 over 4. Okay, so if it's a negative exponent, then it goes to the bottom of a fraction. If it's already at the bottom of a fraction, so let's say 1 over 2 to the negative third, then it moves up to the top. So it's going to be 2 to the third, and 2 to the third is going to be 8. So negative exponent property is going to be really important. This is just a review, but you're going to be expected to know and be able to work with each one of these. Just like anything, like with the 0 exponent, always is going to be 1, or something like when you divide two things that have the same base, you subtract the exponents. So something like if this was 3 and this was 1, this would be 2, 3 minus 1. Which is equal to 2 to the second power, which is equal to 4. So anyway, let's move on. Like I said before, a power is anything that has a base and an exponent to it. So when you have a logarithm, you can switch the numbers around. So when you have something like this, this is your exponent. Okay. Let's see, a and a, this is your base. Okay, that's your base. And then this could be argument. So that's the argument of both of them. So let's get a little example going here. So let's do something like, I don't know, 2 to the fourth. Let's go 2 to the fourth. If I have 2 to the fourth, then it's 2 times 2 times 2 times 2. So this would be equal to 16. So you have your base. Here's my S. There it is. Here's my exponent. And here's my argument. So if you look at this definition of logarithms, you switch things around. So the base is going to stay the same. So this is going to be log. Then your base is going to be 2. So your base down here becomes a 2. The 16 goes on the inside of your log, and then the exponent goes on the outside. So basically the question that you want to ask here is what exponent makes 2 into 16? And the answer is 4, obviously. To exponential form, anything exponential log. Next card. Some properties of logarithms. When you multiply two logs that have the same base, then you add the arguments, or you can add, you can basically split them apart and put a little addition sign here. Here's an example. So if I had log base 3, 9 times x, then that changes into two different logs. Log base 3 of 9 plus log base 3 of x. So you just split them apart and you put your little plus sign. Quotient is the opposite. If you divide on the inside of a log, then you separate them and it becomes a minus. Power, basically your exponent comes out in front of the log. And equality, if they have the same base and they're equal to each other, then the arguments become the same. So something like this. My bases are the same, so my arguments are going to be the same, so I can put an equal sign in front of them. Let's go ahead. Using this chart, we're going to do some problems. So write each equation in exponential form. So if you don't remember from way back when, exponential form is going to be a to the x equals y. And we have log base a of y equals x. Okay, so you can go between the two. So if I have something like this, the base is going to be the same. So here's your base. This is going to be your exponent. And the question asks, what exponent can I give 9 to equal 27? So your base is going to be the same. Here's your 9. And then your exponent is going to be what x is. So here's your exponent. Okay. So it's going to be 3 over 2. And this is going to be equal to your y. And here's your y. So 27. Okay. So here's your exponent. And here's your base. Same thing. Here's your base. So this is going to be 1 over 25. Here is your exponent right here. So I'm going to take and raise it to the power of negative 1/2. And then this is going to be equal to 5. So same thing. If we want to go back into logarithmic form, remember, here's your exponential function, and it's going to be the same number. So I want logarithmic form. Here's the log. I need a base. My base is 7. Okay, so here's my base. And here's my exponent. And here's my argument. Okay, so I have log base 7 of y equals negative 6. And I don't know why I'm not circling my answers. My apologies. And finally, this is going to be log. Here's my base, and here's my exponent. So log base 8 of 1/4. So what exponent do I give 8 to give me 1/4? And it has to be negative 2/3. Questions? Let's move on. So when we talk about evaluating each expression, this is basically where you want to ask that question. What exponent do you give your base to give you the argument? So what exponent does 2 have to get 1/16? So basically 2 to what exponent is going to be equal to 1/16? Well, you know that since the number has to be at the bottom, and you know that 2 to the 4th is going to give you 16. So you know 2 to the 4th gives you 16. You have two things. Number one, 4 is going to give you 16, and if it's negative, my 16 is at the bottom of the fraction, and this is at the top. So it's going to have to be a negative exponent. So with those two things, you know that this is going to probably have to be -4. Okay? So the answer to this question is going to be equal to -4. Okay? This one right here, what exponent does 10 have to get 0.001? Now that didn't look right. So it's not 0.001. Let's go ahead and switch that up a little bit. So this is supposed to be 0.01. So one thing that you need to know is 0.01 is going to be 1/100. So 1 divided by 100 is going to be equal to 0.01. First thing you need to know. The second thing you need to know is 10 to the second power is going to equal 100. So knowing these two things, knowing that you need to have this at the bottom of a fraction, this is going to be log, or not log, I'm sorry. It's going to be 10 to what power gives you 0.01. And that's going to have to be -2 because you need that 10 at the bottom. And so this is going to be equal to -2. And likewise, you need to have what exponent do you give 7 to equal 1/343. And you know that 7 to the third is going to equal 343. So since this is 343 and it needs to be at the bottom of a fraction, then you're pretty sure that the exponent is going to have to be negative. So here is the answer, -3. When we have something like this, solve each equation, we want to still set this up. We want exponential form. So let's switch things up to exponential form. So let's change this up. Base to base. Here's your base. And here's your exponent. So this is going to be 2 to the 5th power is going to equal x. Okay? This equation is pretty easy to solve. So this is going to be 2 times 2 times 2 times 2 times 2. So you're going to get 32. So x equals 32. Number 9, same thing. So if we go to properties of logs, we have an equal sign here, okay? we have, so we're basically going to go to properties of logs. So there's two properties that we have to worry about. Equality, okay, when you have two equal signs. So property of equality, and we're going to have the power property, because you have this 2/3 in front of the log. So if you go back one page to the notes that you took on 2 pages, you have the power property and you have the equality property. So let's go back. Let's set up our equation. And so I have here, so being that we have the equality property, this is going to be n equals, now use your power property first. This 2/3 is going to go over here. Okay, so this is going to be n equals, and then I have 8 to the 2 over 3. Okay, now if you plug this in the calculator, probably a graphing calculator, use your caret, you'll find out that 8 to the 2/3 is going to be 4. So it's going to be n equals 4. So if you use this button on your calculator and you do 8 to the 2/3, you're going to get n equals 4. Next. Okay, so we're solving equations. The property that you want to look out for on your chart is going to be equality. Okay, so basically, if the bases are the same, then your arguments are going to be equal, so those are going to be equal to each other. So you're going to have 4x plus 4 equals 64, okay? And then, you just do your algebra 1 thing. So this is 4x equals 60, so x is going to be equal to 15. And of course, if you plug this mother back in, and you put it right there, then it's going to be log base 6 of 4 times 15 plus 4. So you would have log base 6 of, if you did the math, this is going to be 64, which is what you have right there. So your answer here would be x equals 15. Last problem. So you got a lot going on here. You got a lot going on. The reason that is because, you got 3 properties going on at the same time. So you got the equality property. Okay, because you got 2 logs equal to each other and they have the same base. All of us have the same base. You have the quotient property. And how do I know I have the quotient property? Because you have this right here. And finally, you are going to have the power property, because you know that that's going to have to go there, and this number is going to have to go right there. Okay, so you have the power property as well. So with these 3 things, we're going to go ahead and change these things up. So I'm going to do my 2 little arrows first. And change it up a little bit, so I have log base 6 of 4 to the 2nd power. Okay, so I took my 2 and I put it on top, minus log base 6 of 16 to the 1/4 power. Okay, so I took my 1/4 and I moved it, and this is going to be equal to log base 6 of x. Okay, so we got the power property out the way. Okay, the next thing is the quotient property. So we need to actually make a quotient. We need to make a division problem. So this is going to be log base 6, and if you look at your quotient property, this number and this number are going to have to be on top of each other. But first and foremost, let's do 16, because 4 to the 2nd power is 16, minus log base 6 Now, if you put this in the calculator and you use your little caret key, 16 to the 1/4 power is going to be 4. Okay? And this is going to be equal to log base 6 of x. So now we got quotient property. This is going to be log base 6 of 16 over 4 equals log base 6 of x. So if we simplify, we have log base 6 of 4 equals the log base 6 of x. We've done our quotient property. And finally, since these are equal to each other and the bases are the same, then my arguments are going to be the same. So I have here 4 equals x. So I have x equals 4. And that's my answer right there. So anyway, if you need more practice or if you need another video, as always, I'll be here to help. Fraser Nation signing out.